Hello everybody and welcome to the last map review day 6. Today is all about shapes, 3D shapes, and the probability unit that we just went over. Alright, let's go ahead and jump into it. Number 1 says find the area of the figure. Well, this shape here is a trapezoid. So the area of a trapezoid is base 1 plus base 2 times the height my base 1 and base 2 are here and here. However, this 8.5 is not my height. My height always makes a 90-degree angle with the base. So I don't have it yet. So we're going to have to use some sort of mental gymnastics to find out what it is. Here's how we would do it. I would say that if this part here is 7, that this down here is also 7. And I can do 15 minus 7 and get 8, meaning that between these two pieces I have 8 millimeters. So I'm going to cut that 8 in half and say that each of these pieces is 4 millimeters long. Now you might notice we have a right triangle. So we can use Pythagorean theorem to find out what the missing height is. We'll call this side A, B, and C. So to find out the missing height, I would do 4 squared plus x squared equals 8.5 squared. And we solve this out. Subtract 4 squared from each side. And then take the square root of each side to get rid of the square. And I end up getting a height of 7.5. Now that I know the height of my trapezoid, I can go ahead and plug it into the area formula here. The area is base 1, which is 7, plus base 2, which is 15, times the height, 7.5, divided by 2, which gives me an area of 82.5 millimeters squared. Number 2 says find the area of the figure. And this is a compound shape. So when we have a compound shape, we have to break it down, find the area of each independent piece, and then add them together. This is a trapezoid, so I'm going to use the same formula as over here. This part's a triangle, so I'm going to use the formula 1/2 base times height. Let's start with the trapezoid. I've got base 1 and base 2, and this, because it makes 90 degrees of my base, is my height. So I can say the area of the trapezoid is 7 plus 16 times 9 divided by 2, which gives me 103.5. As for the triangle, I have my base here, but my height needs to go from the tip to the base to make a 90-degree angle. You might notice, again, I don't have that. So, again, just like over here, we're going to have to use Pythagorean theorem using this right triangle here. The entire base is 16, which means whenever I slice it like this part here is 8. Once I know that, I can go ahead and label my sides A, B, C, and do Pythagorean theorem. A squared plus B squared equals C squared. Subtract 8 squared from each side. to get the x by itself, and then take the square root. When I do that, hopefully, I should get 13.86. So my height here is 13.86. Now that I have my base and my height of the triangle, I can go ahead and plug it in. 1/2 16 times 13.86, which is 110.88. With both parts of my figure found, all I've got to do is add them together now to get the total area being 214.38 meters squared. Let's try number 3. Number 3 has a triangle at the back and the same triangle at the front. That means that this is a prism. The prism has two bases, those being the two triangles that I just highlighted. So I'm going to go ahead and draw that triangle out for us right here. It's got a base of 9, side of 8 and 10, and a height of 7.6. We want to find the surface area of the prism. The formula for the surface area of a prism is perimeter times height plus 2 times the area of the base. Well, I can do that. The perimeter is going to be all the sides of my base added up. 10 plus 9 plus 8. That's 27. The height of the prism is different than the height of the base. The height of the base is 7.6. The height of the prism refers to how far apart my two bases are. So my bases go from here to here. How far apart those two bases are is 13. So the height of my prism is 13. The area of the base is going to be the area of this triangle here. So I'm going to do 1/2. The base of this triangle is 9. Then the height of this triangle is 7.6, which gives me 34.2 for the area of my base. Once I have everything, it's as simple as plug it into the formula and let it calculate do the work. Perimeter is 27, height is 13, plus 2 times the area of the base. Plugging all this in, I get 419.4 feet squared. Number 4 says find the area. I've got a half circle. So the area for a circle is pi r squared. For a half circle, we're going to divide that by 2. My radius here is going to be half of 25, so that's 12.5. So area is pi times 12.5 squared divided by 2, which gets me 245.44 meters squared. Number 5. Number 5 says find the volume. Volume for a pyramid is 1/3 area of the base times the height. So, what I've got to do, I've got to find the area of the base, which is this triangle here. the area of the base is going to be 1/2 small b times h. So looking at this picture, I've got the small b, because that's 8. I'm missing the height. So just like how we did on example 2, we've got to find the height of this shape using Pythagorean theorem. This little distance here is 4, because it's half of the total distance. And then I can do Pythagorean theorem. A squared plus b squared equals c squared. And we solve it out. Subtract 4 squared from each side. And then take the square root. And I should get 6.93 for the height of this base, which allows me to find out what the area of this base is. I can do 1/2 8, because that's the base here, times 6.93. Which gives me 27.72 for the area of my base. The h here refers to the height of the pyramid itself, which is 11. With that, I can go ahead and plug in and find out what the volume is. The volume is 1/3 area of the base times the height, which gives me 101.64 meters cubed. Number 6, a rectangular prism has a base. So a rectangular prism has a base that has a width of 5 and a length of 7. A rectangular prism's base is a rectangle. That's why it's called a rectangular prism. It has a width of 5 and a length of 7. So I'm going to say this is 5 by 7. If the volume of the prism is 420 centimeters, what's the height of the prism? Okay, let's reverse engineer this. Volume is area of the base times the height. Well, we can find the area of the base here by doing 5 times 7. And we're told the volume is 420. So I can replace the variables here. The volume is 420, big B is 35, and it wants us to find the height. Well, to get the h by itself, all we've got to do is divide by 35 on each side. And I get 12 equals height. Number 7, find the surface area of this cone. Well, the formula for the surface area of a cone is pi times radius times the slant height plus pi r squared. The radius is 9, but the slant height we don't know yet. So again, we're going to have to use Pythagorean theorem to find out what the missing slant height here is. In this case, this would be A, B, and C. So I would say 9 squared plus 14 squared equals x squared. Luckily, all the numbers are already on one side, so all I got to do is square root it and get a slant height of 16.64. With that, simple as plug and chug. Pi times 9 times 16.64 plus pi times 9 squared. And we should get 724.95 inches squared. And the last shape question before we get into probability. Number 8. A rectangle has an area of 104 centimeters. So here's my rectangle. The area is 104 centimeters squared. and a width that measures 8 centimeters. Find the height, and then find the perimeter. So if this side's 8, this is also 8 up here. The height we're going to find because we can say that length times height, 8 times x, equals the area, 104. Well, we divide each side by 8 and get 13. So that means that both of these sides are 13. And then to find the perimeter, I've just got to add up all the sides. (13 plus 13 plus 8 plus 8 gets me 42. All right, the hard part's done. Now it's all downhill. I lied. Number 9. Last shape question, sorry. Find the volume of the cylinder. The volume of the cylinder is pi r squared times the height. The r is 7, and the height is 18. So we just do pi times the radius squared times 18, which should give us 2,770.88 yards cubed. Now we're on to probability and statistics. Number 10 says a teacher is trying to make a group of 5 students to help carry chairs to another room. If the class size is 30, how many ways can he choose the 5 students? These are 2 keywords that point me to a combination. With combinations, we use the NCR function on our calculator. My N is the total number of people, so 30, because it's a 30 size class. And my R is how many people are going to be in the group. So there's going to be a group of 5 students. Well, I can plug this into Desmos. NCR 30, 5, and I should get this crazy big number. Number 11. A card is selected at random from a standard deck of 52 playing cards. What's the probability it's an ace, 2, or 3? Okay, remember, probability is always a fraction. It's success over total. So, I've got 52 total playing cards in a deck. And I want to find out how many are aces, 2s, or 3s. Well, there's 4 of each type of card in the deck. So there's 4 aces, 4 2s, and 4 3s. Adding all these together, I get 12 possible successes. And then we simplify. I can divide top and bottom by 4 to get 3 out of 13. Number 12. An ice cream shop offers a choice of 3 cone types, 12 flavors, and 8 toppings. How many different ice cream orders can be made? So, I've got 3 slots, cone type, flavors, toppings. I've got 3 possible types of cones, 12 possible flavors, and 8 possible toppings. All I've got to do is multiply these things together, and I should get 288 different types of orders you can have. Number 13. How many different 5-letter arrangements can be made using the letters in the word chair? Okay, well, the word chair has 5 letters. And so for this first slot, I can put any of the 5 letters. So I have 5 options there. Once I put a letter there, I can't repeat it. So it's going to decrease by 1 and become just 4 options for the next slot. This is going to repeat itself until I just have 5 times 4 times 3 times 2 times 1, which is 120. So there's 120 different letter arrangements I can make. Number 14. A bag contains 25 red chips, 18 blue chips, and 29 yellow chips. A chip is selected, replaced, then another chip is chosen. Find the probability of choosing a blue chip, then a red chip. Notice we're saying it is replaced. So my total is going to remain the same from one chip to the other. We're also talking about probability, so I'm going to have two fractions multiplying each other. First, I need the total number of chips. Adding up 25, 18, and 29, I should get 72. So, first, I'm going to grab a blue chip. Out of the 72 total chips, there are 18 blue chips. So that's the probability of me getting a blue chip. Then I'm going to multiply it by the probability of getting a red chip. Remember, we took the chip out and then we put it back in the bag, so my total didn't change at all. However, this time I'm looking for red chips, and there are 25 red chips. So my top number is going to be 25. Plugging this into Desmos will get us a simplified answer of 25 over 288. Last but not least, Carter is handing out Valentine's Day cards to his friends. He has 8 Batman cards, 12 Superman cards, and 5 Captain America cards in a bag. What's the probability that the first 2 he chooses are Batman? Well, first off, we need to find the total number of cards he has by adding up 8, 12, and 5. That gets me 25 total Valentine's Day gift card or cards in the bag. He's going to give them away to his students, so the total is going to decrease between each event. We want to find the probability that he gets Batman first and second. So, he reaches in his 25 card bag, and there are 8 possible Batman cards. So that's the probability of him getting the first card as Batman. Once he gives away the first card, he has less cards in his bag now. He has 24 cards in his bag now. He also gave away one of the Batmen. So instead of having 8 Batmans, he has 7 now. Multiply top to top, bottom to bottom, and this simplifies to 7 over 75. All right, I know that was a lot. The front page can be fairly daunting for a lot of people, but generally, you will have a formula chart, and if you can find the missing pieces, it's just plug and chug. I hope you have a fantastic rest of your day. For Mr. B's class, these will be due on Monday. If you're in Mr. A's class, he'll tell you when they're due. Otherwise, I hope you all have a fantastic day. Goodbye.